Hello. So let's start today class. Just, okay, so in the previous class, we discussed about the chemical energy storage, that hydrogen energy storage. Okay, in which hydrogen energy storage, how we can store their hydrogen energy and their production of hydrogen. So today we are going to discuss mm, about the types of fuel cell. Okay, so first you share the screen first. So let's start today class. As we seen in the previous class, that means chemical energy storage, hydrogen energy storage. Okay, so today we are going to discuss types of fuel cell. Under this, we just discuss classification of fuel cell, alkaline fuel cell, and phosphoric acid cell, fuel acid cell. Okay. So these are the classification of fuel cell. Okay. Classification and alkaline fuel cell and phosphoric acid fuel cell. So just we will see here one by one. Okay, what are the various classification of fuel cell and their explanation one by one. And next is alkaline fuel cell, how they can produce the alkaline fuel cell and about their explanation. And last one is about the phosphoric acid fuel cell. Okay, so just we try to see here one by one. Just one is your classification of fuel cell. Okay, what are the various types of classification or the fuel cell? So just try to see here. There are the main four classification. One, these are the fuel cell technology can be classified in many ways. The classification can be based on the various categories such as is the fuel and oxidant combination. Okay. Second one is electrolyte, and third one is temperature, and last one is the application. Okay. So these are the classification technology for the fuel cell. Okay. That means fuel and oxidant combination. What is the main material for the fuel and their oxidant? So combined in this manner that will produce the fuel cell. Okay. And second one is electrolyte, third one is temperature, and last one there is application of the fuel cell. So we will just see one by one, and later on we will discuss. Okay, so just concern about the classification of fuel cell. Okay, so what are the various fuel and their oxidant combination? First one. So just we will try to see here. Is not so just try to discuss about the oxidant combination and just fuel and electrolytes. So just these are the four classification fuels. Their temperature can, what are the various category of the temperature? What is the uh, low temperature, medium temperature, and high temperature and very high temperature. Okay. So just we try to see here one by one. So just first one. Okay, that means the fuel and oxidant combination. So classification based on physical state of the fuel. Either it may be there, you maybe know that there the material maybe physically any material can be exist either in the three way, either any materials. So we can say here that the any types of material physically can be state in either gas form, liquid form, or solid form. They are the physical state of the material. Okay. So we either maybe talk about the gas. So which are the fuel just under the gas we can found. One is already discussed in the previous class also about the hydrogen. Okay. So hydrogen may be consist in the form of gas and lower hydrocarbons. It is also found in the gas form. Okay. And if you concern about the liquid state, okay, or the physical state of the liquid state, then you may find out the various fuel, just like as alcohol are found in the liquid form, hydrogen, it is also found in the liquid form, and hydrocarbon. Okay. So these are the basic fuel we may be found out in liquid form. Okay, and last one we concern about the solid state. Okay, fuel. So under the solid state fuel, you maybe find out some metal hydrides. Okay, about their metal hydrides. Uh, we also were discussed in the last class. Okay. Okay, so metal hydride found in the physical state of solid. Okay, so these are the classification of fuel and oxidant combination. That means fuel, mainly fuel, found in uh, three physical state. Okay, you may be considered either a fuel cell of gas form, maybe consider a fuel of the liquid form, or last one maybe you find concern about the fuel of the solid form. Okay, solid state. So this is the state of uh, physical physical state. That means of fuel may be considered either the gas form, liquid form. During the gas form, we just concern about the hydrogen and lower hydrocarbons. And for the liquid, just maybe concern about the higher carbon hydrocarbons, alcohol, and hydrogen. So okay. So these are the physical state of the fuel. Next one, just we try to see here. Electrolytes, second one. Okay. Electrolytes. So electrolytes, we find out their most classification by electrolytes. It will be aqueous, non-aqueous, and molten, or solid, alkaline, and acidic. Okay. So electrolytes material you will find out in various form. That means will be aqueous, non-aqueous, and molten or solid, alkaline, and acid. So under this we find out the first one as the alkaline fuel cell. Second one, that means classification phosphoric acid fuel cell. Okay. And next one is nothing but molten carbonate fuel cell. Fourth one is solid oxide fuel cell, and last one, that is proton exchange membrane fuel cell. Okay, so these are the various classification of electrolytes. Okay. So common classification based on their electrolytes, you can say. Okay, if we use this material, okay, in some of the aqueous form, non-aqueous form, or some of the maybe in molten or solid alkaline and acidic. Okay, next one, we just this is all about the electrolytes where we use in the okay. So next one we just concern about the temperature. Okay, we already there some point we already classified about the classification of fuel cell. Okay, and alkaline fuel cell and phosphoric acid fuel cell. So if we talk about the temperature, okay, that means the third one about under the classification of fuel cell. Okay, so we already discussed about their fuel and oxidant combination, and second one we already discussed about the electrolytes. Okay, and third one is about the temperature. So fuel cell may be classified by temperature range. Okay, where the temperature may be classified in the various category, either in low temperature, medium temperature, and high temperature. Very high temperature or the cell operation. That means under the low temperature, we can say that the temperature lie between the so temperature, that means fuel cell may be classified by temperature range. Means a low temperature, we can say that about the range for the low temperature 25 to 100 degrees Celsius, and in medium temperature, that means 100 to 500 degrees Celsius. You can say that under this range, we may be considered as the medium temperature. And for the high temperature, we maybe say that from 500 degrees Celsius to 1000 degrees Celsius classified as the high temperature. You know, and above the high, above the 100 degrees Celsius, we may be considered as the very high temperature. Okay, so these are the classification on the basis of temperature. So if any cell operate at the temperature 25 to suppose that 35 degrees Celsius and 65 degrees Celsius, 95 degrees Celsius. So these are the low temperature under the category of low temperature. Okay. So suppose that someone operate at the 130, 195 up to 500 degrees Celsius. That means we may be considered as 490, 495. So up to these and 490, these are the category under the medium temperature. Okay. So we can say that if you remember about the range for the classification of temperature, low temperature, which one say that low temperature, medium temperature, and high temperature, and very high temperature. Okay. So on the temperature range, you can identify which type of if suppose that operating temperature is given, then you maybe find out under which category it will fall. Okay, either in low temperature, medium temperature, or high temperature, or in maybe very high temperature. Okay. So you have to keep the range of the temperature 25 to 100 degrees Celsius under fall under the low temperature, and 100 degree to 500 degree fall under the medium temperature, and 500 to 1000 degrees Celsius fall under the high temperature, and whatever the temperature range from above the 100 degrees Celsius. Okay, starting from 101, 100 and above. So we will consider that this is under the fall very high temperature. Okay, so this is all about the temperature range. And last one we just concern about the application, okay, of the fuel cell. The application of fuel cell. Just we already said that there. So next one is alkaline fuel cell. Okay, alkaline fuel cell. We already know that in any cell consists of main three components. Okay, one is anode, one is cathode, and one is electrolytes. These three are main parts of any cell. Okay, so alkaline fuel cell use potassium hydroxide. That means their chemical formula may be represented as KOH, potassium hydroxide, as the electrolytes. Okay, and in this also use some other alkaline aqueous solution. So for the electrolytes in the alkaline fuel cell use the potassium hydroxide, and at the anode fuel electrodes we use hydrogen at the anode, and at the cathode we just use nothing but oxygen electrodes. That means oxygen. Okay, and electrolytes we use the potassium hydroxide. So these are the three: cathode, anode, and electrolytes. Okay, for the cathode we use just oxygen, and for the anode we use the hydrogen. Okay, so we know that the cathode and anode of fuel cell is separated by the electrolytes. Okay, we already seen in the their previous classes also. Okay, so cathode is nothing but the represent the positive terminal of the cell, and anode is represent the negative terminal of the cell. Okay, so you may find out the flow of current direction, that means cathode to anode, and the flow of electron, that means reverse of the current direction. So you may be concerned about the, and their cathode and anode are separated with the electrolytes. Okay, so for electrolytes we use the potassium hydroxide, that means KOH, and at the cathode we use just oxygen, and at the anode we use the hydrogen. Okay. So the next one we just discuss about the major difference between the acidic and alkaline electrolysis. Okay, what is the difference between the acidic and alkaline electrolysis? So acidic electrolytes, the major migration is by hydrogen, that means represented by H plus ion. Okay, in acidic electrolytes, and in alkaline electrolytes, the major migration is by the hydroxide, that is represented by OH minus. Okay, ion. So these are the difference between the acidic and alkaline electrolysis. If you use the acidic electrolysis, that means the hydrogen plus H plus ion, or in alkaline electrolytes, the major migration is by the hydroxyl that is represented by OH minus ion. Okay. So this is concerned about the difference of between the acidic and alkaline electrolysis. Okay, their migration how we can done in the acidic electrolytes and alkaline electrolysis. So you have to consider about their H plus ion and hydroxyl ion. Okay, that means OH minus. This will operate on the compressed hydrogen and oxygen, and the operating temperature is low. It means, example, we can say that from low temperature, right, between the under the which category 100 to 500. So example, we maybe consider that 150 to 200 degrees Celsius. Okay. So at the anode, that means you will find out here the electrical circuit alkaline fuel cell for the alkaline fuel cell. Okay, that means you will find out here the oxygen put, and from this we just supply the oxygen, and through this we just input the hydrogen. Okay, so these are the cathode and anode terminals, and this separated by the OH minus ion. That means H2O. This oxygen just come here through this path, and this cathode terminal you will find out at this point. Okay, so electrolysis is electrolyte use OH minus ion. So make the at the terminal, the OH minus ion electrolyte interact with the hydrogen. Okay, in the fuel. So electrodes give the water and electrons. So when this oxygen come here and with the electrolysis of OH minus make the reaction of H2O and release the electrons. Okay, so electrons flow from this direction to this, and electric current maybe find out they are the opposite direction from the flow of direction of electrons. So if electron flow from this point to this point, so we can say that the path for the current, that means cathode to anode terminal. Okay, and here again water is head out from this path. Okay, so this is all about the alkaline fuel cell. We have to concern about the in one direction put the oxygen, and hydrogen, input the hydrogen. Okay, so this cathode and anode are separated with the electrolytes. So that means here make the reaction of H2O and release the electrons. Okay, that means 2 H2O plus electrons with this one. Okay, 2H. So this is the representation for the alkaline fuel cell. You will find out their cathode terminals, anode terminals, and electrolytes. Okay, this is the diagram. So the next, just we see there at the cathode terminals. Okay. So you will find out at the cathode terminal, that means their reaction that the produced water and electrons at the we find out are combined with oxygen at oxidant electrodes from the hydroxide OH minus ion. Okay. So 1 by 2 plus H2O plus 2 electrons make the 2H minus ion. Okay. Just to find out from this diagram. Okay. So 1 by 2 oxygen here. Oxygen and two electrons with the make of hydroxyl ion OH minus and make the hydroxyl ion. Okay, so oxygen at the oxidant electrodes from hydroxyl OH minus ion. That means 1 by 2, 1 by 2, 1 by 2 O2 plus H2O plus 2 electrons make the uh, hydroxyl ion, that means OH minus ion. Okay, so just maybe some about these things. Okay. So this is the representation of alkaline fuel cell. We find out the connection of load, how we can connect through the alkaline fuel cell. Okay, so we already seen in the previous diagram. That means from here we just input supply of the oxygen, and from this path we just supply given the hydrogen. Okay, and at the cathode terminals it makes the reaction, and electrolytes separated by that is nothing but hydroxyl ion, that means OH minus ion. Okay, and it makes the after the reaction here with the oxygen, H2O and electrons. Okay, so electrons flow from anode to cathode if we connect the load. Okay, that means if you connect the load, so the electrons flow from this anode path. Okay, so sorry, the flow of electrons, you may find out this one is your element here. This one is red one is showing the hydrogen, and this one OH. So hydroxide, this one represent hydroxide ion. Okay, that means OH minus. And from this path, this one is representing O2. That means oxygen. Okay. And through this one, red one, you may find out the input of hydrogen, and after the reaction, it will be make the water. So take out from this path, and electrons. So electrons flow from this anode to the cathode, and current flow from this cathode to anode. Okay. You maybe this one represent as the alkaline fuel cell of the electrical connection, how we can connect the load with the alkaline fuel cell or alkaline fuel battery. Okay, their cathode terminal, anode terminal, and electrolytes and the load connection, how we can just put the hydrogen and oxygen. So just from this path you may find out the flow of electrons from this to anode to cathode, and this oxygen make out of from this vessels. Okay, so this is all about the connection diagram and their flow of electrons and their reaction in the alkaline fuel cell. Did not. So just maybe concern about their flow of electrons and flow of current. Did not. So maybe draw this diagram. How can they make the reaction of hydroxide in the electrolytes and oxygen of the cathode? Okay. This is all about the reaction. That means a hydrogen and oxygen make the H2O and hydrogen. Okay. Release the one hydrogen. So the overall reaction, that means H2 plus 1 by 2O2 make the H2O, and hydrogen. The net reaction in the cell is hydrogen and oxygen. Okay, between the reaction between the hydrogen and oxygen supplied to the fuel cell produce the electrical energy. Water and heat are the byproduct. Okay, so with the water and heat with the help of hydrogen and oxygen. So this is all about the how you can make the reaction of hydrogen and oxygen. So this will produce the water and really the heat as the byproduct. Okay. Next, just want to discuss. Yeah, first one in the alkaline fuel cell, we may find out their efficiency is about the almost 70%. This type of alkaline fuel cell. The output range maybe in power 300 watt to 500 kilowatt. Okay, so talk about the alkaline fuel cell, up to which power rating we can use this type of fuel cell. I started from low power to almost 5 kilowatt. Okay, so this is range of the power for the alkaline fuel cell, and efficiency we may be consider almost about the 70%. So these are used in this submarine remote site. Okay, that means you may find out installation of this type of fuel cell in the submarine uh, in the sea, where the backup of power at the large power up to 5 kilowatt. Okay, and also in Apollo spacecraft uh, to provide both electricity and drinking water, where we can generate the water. Okay, so this is the application of alkaline fuel cell. How you can, okay, in submarine and space aircraft also. So they required pure hydrogen fuel, however, and their platinum electrodes catalytes are expensive. So you have to keep in your mind these specific data about the application of the alkaline fuel cell, and there what is the power rating started from 300 to up to 5 kilowatt, and about their efficiency. So this is all about the alkaline fuel cell, their systematic arrangement between the and which type of material used at the anode and cathode, and which are used at the electrolytes. Okay, and what is their efficiency and power rating for this type of battery. Okay, so they require pure hydrogen fuel. Use hydrogen, the main fuel in the alkaline fuel cell. Okay, however, their platinum electrodes catalytes are expensive, so we can consider it for the electrodes. Okay, because it may be find some expensive. Okay. So this is all about the alkaline fuel cell. Maybe concerned about their all data and systematic arrangement and the chemical reaction, how we can make the hydrogen and produce the heat. That means you may find out this reaction. Okay, hydrogen and 1 by 2 oxygen make the water and release the heat. Okay, so this two we consider this one. Okay, so next one is phosphoric acid fuel cell. Okay, phosphoric acid fuel cell. So use in this type of fuel cell 100% concentrated phosphoric acid, that is represented by H3PO4, is an electrolytes. So you have to concern about this type of electrolytes used in a specific fuel cell. Okay, we already seen in the previous for the electrolysis potassium hydroxide used in the previous cell. Okay, alkaline fuel cell. But here in phosphoric acid fuel cell, we use phosphoric acid, that means H3PO4 is an electrolytes. And at the anode, hydrogen fuel electrodes, and at the cathode, we use the oxygen oxidant electrodes. So electrolyte may be different compared to the alkaline fuel cell, where we use the uh, hydroxide, that means OH minus ion. Okay, OH minus ion. But here we use H3 PO4, H3PO4. Okay, sorry, concern about their chemical reaction. You will find out in the phosphoric acid fuel cell. The ionic conductivity of the phosphoric acid is low, so the charge carrier is hydrogen ion, H plus ion. And at the anode, you will find out their chemical reaction. That means hydrogen molecule 2H2 is split into hydrogen ion, that means proton and electrons. Okay, so 4H plus and plus 4 electrons released from the hydrogen molecules. The electrons flow through external circuit and produce electric power. The electrons flow through external circuit and produce electric power, while hydrogen ions travels through electrolytes. Just about the at the cathode terminals, you will find out the oxygen usually from air is combined with hydrogen ion and electrons from anode to for water. Okay, so here you will find out the production of water, that means oxygen and hydrogen from this side, and with the electrons make the chemical reaction and produce the water. So this water we will take out from this path, and oxygen will be supply given through this path, and hydrogen through this one. Okay, so make the relation, that means oxygen and hydrogen plus some electrons, that means 4 electrons. So make the hydrogen and take out from this path. Okay, at the cathode terminals. So this is the overall reaction. That means two molecules of hydrogen and oxygen. So make the water and release the heat. Okay, this one is release the heat. So that means hydrogen. Okay, water and make the hydrogen. So this is all about the phosphoric acid fuel cell. Okay, phosphoric acid fuel cell, and this we find out some part, that means operated at phosphoric fuel cell 150 to 200 degrees Celsius, and the overall efficiency approximately 85% more compared to previous one alkaline fuel cell. So the cell output range from 50 to 200 kilowatt. So capacity is also increased here, power capacity for this phosphoric fuel acid cell. These are used for the stationary power generator, and these are used in large vehicle like buses. So it has low power density. It's a dangerous disadvantage. Okay. So just we stop here, and in the next class we will discuss another things.